Hi, this is Rahman Sheikh. Welcome to Fortnightly Railway Transportation Systems podcast. I am the host and railway systems specialist. This podcast is primarily focused on railway experts who have vast amount of experience and contributed greatly to this amazing industry. This is not a technical seminar but focuses on feel good stories, individual journeys, their success and failures, motivating younger generation to kickstart their career in railways and creating a sense of pride for the railway people who devoted their lives on the most environment friendly public transportation. Today on Railway Transportation Systems, we are joined by Ivan Ristić, a highly accomplished railway signaling and telecommunications engineer with over 26 years of continuous experience in the railway industry, holding a master's degree in electrical engineering from University of Belgrade. Ivan has led transformative infrastructure projects across Europe, the Balkans, and Africa. He brings deep expertise in the full life cycle of railway signaling systems, from design, technical verification, and a safety case development to site supervision and certification, spanning legacy systems to cutting-edge technologies like ERTMS, ETCS Level 1 and 2, GSM-R and CBTC. Ivan has worked on numerous high-profile initiatives funded by the European Commission, EBRD, and the other international organizations, modernizing over 100 stations and contributing to national ERTMS programs. As a member of the Institution of Railway Signal Engineers and an author of multiple technical papers, his leadership at Signaling Solutions DOO continues to shape and efficient rail networks. We are delighted to learn from Ivan's extensive experience and insights into delivering modern railway signaling solutions on some of the world's most challenging projects. Hi Ivan, welcome to the pod.
Hi Rahiman, thank you for invitation and thank you for this nice introduction, nice words to be part of this podcast.
Let's start with your career journey and foundations. Ivan, you have built an incredible 26 years career in railway signaling and telecommunications. What initially drove you to this field and how has your perspective evolved over the decades?
Okay, I was actually driven to this specific niche of railway signaling and telecommunication by some lucky circumstances in my career. I finished the telecommunication studies on my studies, and I received a scholarship from one company. So what I actually expected is to be in some high-tech ICT job, which was then very popular in the 1990s. But actually, since I started to work, I was assigned to the railway signaling department in one company, state-owned company, which is part of the railway infrastructure manager. So although this seemed strange and unknown to me because there was no part of education during my studies, I gradually was interested, starting to learn more and more, and somehow stayed in this niche for up to date. And what was also important, the timing, when I started in mid-1990s, then there was really big leap in the expansion of railway signaling, and at that time the first electronic interlockings, and then also later in the 2000s introduction of ETCS system as another leap in technology. So I was also happy with timing of starting my job. So basically this was the background how I ended in the railway signaling.
That's a fascinating journey, Ivan. It's amazing how those unexpected twists, like stumbling into railway signaling from telecom, can shape such a remarkable career, mate.
Yes.
I love how you embrace the challenge and grew to love it. Keep loving it.
Yes.
Especially during that pivotal shift from a relay to electronic interlocking and the rise to ETCS. Can you share from influential projects that felt like a game changer for you? Which projects actually stand out as milestones in your career, and what made them particularly challenging and rewarding?
Yes, of course. Well, first, as I said, in the 1990s, the beginning of electronic interlocking, which actually came into the installation in Serbia in 2003. That was a project led by Siemens, and with the installation of Siemens W interlocking device, I think it was one of the first in Europe. So basically, at that time, we were designers, so cooperated with the Siemens engineer in the development of this design and the whole technology, which was not fully known by us. So this was really remarkable and big experience. Follow up the first electronic interlocking from the design, then up to the commissioning. We were also following the on-site test, measurements, different maintenance techniques, and so on. So it was really very, very precious for further upgrade of the knowledge. Then also, I would also highlight my first big international project where I worked in Tanzania in 2013 and 2014, where there was also a design of TCS Level 2 and electronic interlocking on two railway lines, which were almost 1,000 kilometers long. So this was first important from the technological view, and the other also because this was really good and international team with a lot of experts from different backgrounds and disciplines. So in this sense, this is how I first time learned to work in such big teams. Learned a lot. It was for COVID Denmark, and I learned a lot of, let's say, these procedural, not just technical issues on such a big projects. And of course, I would say that the third one, which is still not fully completed, but it's done in phases. This is the first ETCS Level 2 project of the high-speed rail in Serbia. So we also participate here as a company from very beginning in 2017 when the contract was signed. Helped the railway infrastructure manager to develop first specifications, then some operational scenarios for work, then later participated in the design phase, then also in the verification phase with use of some new tools for the TCA testing. So the first section is in operation already 3 years, and the second section should be put in operation just next month. So this was really a big project, and the home country where really learned a lot about this technology from the first hand.
Wow, incredible milestones, Ivan. Each one seems to have added a new layer to your expertise. So let's transition into technologies because you started talking about technology. You have worked in both legacy and modern systems. What are the key considerations when upgrading traditional signaling systems to ERTMS or ETCS or CBTC in existing networks?
Yes, well, just to mention, this still didn't start it, but for the previous question, now we expect also start of the first CBTC project in Serbia, where Alstom will be engaged as a contractor of the first line for the Belgrade Metro. So this is also one milestone which comes very soon. But generally, from experience from all other projects, I would say that there are a few items which should be worth mentioning. First, it's very important to have some phase development of each project, also very synchronized with the funding of the project, with the regulation of works during construction. Then also, of course, since you're doing the migration, then the migration philosophy is very important. So sometimes it is just overlay that both systems are working in parallel until new system is fully commissioned. Sometimes it's split, so it's just cut over. For example, what we had here in Serbia, simply the line was closed, so the old system was not used, and just when it was completed, we put a new system, or there could be something between, some kind of stage implementation with transition from one system to others. Then also operational concept and traffic management of the whole project is very important. It's not just how you create the infrastructure, but you also need to have good management, for example, CTC, or even now some modern traffic management system with automation of train scheduling and everything, which we also had on this project completely with ETCS level 2. Then, of course, when you need to choose about some feasible solution for you, it must be done some analysis whether it's functionally and operationally adjustable. For example, are you going to level 1 or level 2? For example, we also have in the meantime one secondary line commissioned with level 1. You always need to make some balance between the functionalities and actual demand of the line, or also on the metro system, CBTC. You usually now modern systems are either grade of automation 3 or 4, depending of course of your actual targets, headways, capacities, and so on. Then also now very important issue is migration of the radio communication systems, which follows this. For example, we in Serbia use GSM-R still, but now with the introduction of the FRMCS, we have planned for new lines to be commissioned with FRMCS. For the metro system, these are usually some kind of LTA networks. So you also need to create the migration, because you probably will not have all the fleet equipped at one time. So you probably will need some kind of overlay. Then, of course, also very important issue is to train staff who will be in maintenance, and also staff who will be in operation of these systems. And that's very important to be properly done by the supplier. Of course, to use some testing and simulation tools later stages after system is commissioned. For example, here our railways bought one very good system, ERTMS camcorder, from one Belgian company, which is used to regularly check the line and the technical parameters of the line, like checking the real telegrams, interlocking, juridical unit, and everything. Very good tool, which actually synchronize all the data which is in flow in the system, and checks if there are some mistakes. And of course, what is also important, you need to, in order to be interoperable with the whole network, in our case with European network and the TCS network, you must also conduct corresponding regulatory authorization. You need to pair the new laws and bylaws, which regulate not only the technical part, but also the procedural part. How do you access the network? How do you, for example, sell keys for ETCS and so on. So there are a lot of important issues, but I think this is some basic which should be respected in this case.
Wow, lots to take in, Ivan. Thanks for sharing. Your insights really highlight the complexity and precision needed for these transitions. It's clear that you have navigated these challenges with incredible expertise, Ivan. So let's move to your ERTMS journey. As someone who has contributed significantly to the national ERTMS programs, how do you see the adoption of ERTMS evolving globally, especially in countries just starting this journey?
Yes, that's a good question. And I can, let's say my experience here from Serbia, but also from some other countries where I followed the implementation in one or other way, especially if you're starting like greenfield from scratch. This may be even better case because then you need to prepare all regulations and everything in advance. So it's very important that you have the complete framework, regulatory and technically, before you go into the procurement. For example, here we had first prepared the ERTMS implementation plan, which contained some data about years where specific railway lines will be equipped, also with which levels, whether there is a GSM-R or no. So you need to have some strategy for long term. Our plan was including 20 years in advance. So then when you go to the specific client, specific project, then you need to prepare the user requirement specifications, because there are a lot of issues outside of TSI which is left to the national authorities. This is one of the, let's say, mistakes that some people think that TSI regulates everything. No, actually you have a lot of so-called national parameters which you need to define for your own country, having in mind some specific of operations and systems which you have. Then when you prepare operations, so-called operational scenarios, where you actually choose which of the different modes of EPCS you will be using in your country, how you will transit from one mode to another, and so on. And these two documents will be, let's say, together with the plan, enough for the procurement phase, for the suppliers to give a good offer. But then also for your further commissioning of the system, you need also to develop specific test cases, how you will test this, how detailed also, which include also track part and the onboard track. You check also compatibility with the onboard part of the TCS. Then you also need to consider different baselines. Now we have actually 4 baselines different in operation. So you need to, let's say, predict at least basic scenarios, how you will handle different baselines on the same line and so on. So basically this regulatory framework is very important. And for us, it took several years to prepare this in advance to the start of the implementation of the project.
Great insights, Ivan. Thanks for sharing. This is gold dust. Now, you have picked GSM-R, so let's go to GSM-R. As GSM-R has been backbone for railway communication, with the move towards FRMCS, how do you see this transition impacting signaling systems in the coming years?
Yes, this is also very, very good and very actual question right now, because as you know, now there is on the worldwide level, there is a transition between these two systems. GSM-R is gradually will be abandoned. In Europe, generally the obligations of the suppliers are to provide spare parts still in some period between 2030 and 2035, depending on the country. But after 2035, actually, there will be no mandatory requirements for GSM-R spare parts. So actually, you need to predict something for the future. On the other side, FRMCS, the specification, the first draft of specifications was written in the new TSI from 2023, but it's still not operational. The update is expected by the end of 2026, and then there will be some pilot implementations, several railway lines in Europe, and it is expected that it could be commercially available from 2027. So basically, for now, GSM-R is still the only available solution, but it has some limitations. For the transmission of signal information, it's still sufficient, but generally for development of telecommunication services, especially on board on trains, now you can have like IoT, Wi-Fi on trains, everything. The GSM-R with its narrow frequency band is not enough to transmit all this information. So basically, more or less, you need to predict some kind of transition if you already have GSM-R, or if you plan to go to the greenfield, then it's better to start with the FRMCS, because it's not so far away from commercial implementation. But definitely, each country, especially in Europe, has developed some migration strategies for this issue, both for the infrastructure part and especially for the trains. Some of the big suppliers of the onboard parts, like Kontron, like Funkwerk in Nokia, already prepared solution of equipment on the train. And good news is that this GSM-R equipment could be adapted on trains to work with FRMCS, so you don't need to buy completely new equipment. There will be just some kind of adaptation of existing equipment. But definitely it's important issue now for all countries because the GSM-R is going toward its commercial end.
This transition sounds like a monumental task. Oh my God. So let's shift towards certification and safety cases. So you have led certification and safety case development for many projects, as I said in my intro. What are the common pitfalls teams face in meeting CENILAC EN standards, and how can they be avoided?
Yes, I worked on several preparation of different safety cases for some of the suppliers, for example, so-called internal safety case, but also on several projects I was working for some independent safety assessment companies as an assessor. So basically, yes, this could be very challenging. From my experience, always one of the most critical issues is somewhere on the boundary between the system which you work and some existing system where you connect. Usually these are relay interlockings. So when you replace part of the line with electronic, you will have some kind of interface with the relay technology. And in these cases, it's not easy to demonstrate the overall seal for compliance for this whole system. So in this case, you need to also have a very good documentation as a supplier to prepare steps for each of these phases in the life cycle of hardware and software according to EN standards. And usually it comes as a result that you have some specific safety relation application conditions. For each project, they can be very different. For example, especially if you were using the components from several suppliers. For example, you have electronic interlocking from one, X counter from second supplier, level crossing for third supplier. So giving their mutual integration into terms of the seal level could be challenging, and it requires, let's say, good knowledge and a lot of documentation, especially if you are preparing this for the external safety case for the independent safety assessment. If you are already doing the independent safety, it's easier because then you are just verifying what's already prepared. But when you need to prepare this for the supplier, this is really a challenging. So, for example, we have done here with the Chinese supplier for preparation of their internal safety case, and we have several different interfaces with the relay interlocking, with the existing relay CTC system, with another electronic interlocking from other suppliers. So there was challenging, but at the end we managed to obtain the overall seal for confirmation from the independent safety assessment. So it's a challenging process and requires a big knowledge of all systems which are affected in the project.
I do agree 100%. Thanks for sharing, Ivan. Now I am looking ahead. I'm shifting a gaze from question to question. Future of rail signaling, especially with CBTC implementation. CBTC is often associated with urban metros. So, Ivan, what are the unique challenges of integrating CBTC into brownfield metro sites compared to greenfield projects?
Yes, well, for example, the project which I mentioned here for Metro in Belgrade is a completely greenfield project, so this will be easier to implement because there is nothing existing. But for the brownfield projects, it is very, very important that you prepare a very good strategy before any procurement. First, especially, it's important to keep and maintain passenger service during migration. So it means that you will need some kind of overlay of both systems, which further means that you will need to have different onboard systems on trains. And also you need to then very precisely plan the cutover between two systems, how and when this will be done. So the converting of existing line is always more complicated, and also there are some other aspects which you need to consider. For example, now you can also read some interesting articles about this on LinkedIn. So this is the procurement strategy. Even if you're doing just one line, you need to consider further extensions or other line which will be in plan, because as you know, for the CBTC we don't have still the interoperability standards unlike ETCS. So basically, if you don't plan this well, you will probably end up with just one supplier for all your future lines, because there is no technical compatibility between different suppliers. So you need not just to plan this line which you are now working on, but also the future lines and extensions, in terms that you maybe need to have a pool of suppliers and to require their compatibility in advance. So for example, some projects in Australia and USA, they always select two suppliers, one main and one spare, but just one will have the job, but they ask for both to demonstrate compliance. So in case that something happened with this one, that they have a ready replacement. So this is also a very important issue to consider wider scope than just the project which you are now working on for CBTC, because of lack of interoperability.
100%. Moving to leadership and engineering, as a team leader and key expert, how do you approach leading multidisciplinary teams to deliver complex signaling projects successfully?
Yes, this is also a very good question for all engineers who are involved in railways. I have been a team leader or project manager on several projects, mostly in the design stage. And in this case, you really need to have the understanding, at least basic understanding of all other include specialties in this project. So, for example, although I am electrical engineer, I was leading team where there is also track engineers for alignment, electrification, structures, traffic operation. So in order to plan the project phases properly, you need to actually know about all of these disciplines, these basic things. So for example, when you're doing design, then you first need input from the track design, and then after that goes the electrical guys, signaling, telecommunications. Then you have to check with the structures if there are some bridges, tunnels, how to handle cables. Then you need also architects. You are building new buildings, you need to give them inputs for the equipment and so on. Then the mechanical engineer for the FAC and everything. So basically you need to know the technology of the whole project in order to properly phase the project activities. And that of course require a little bit education from all of these disciplines. So basically you need to have a wider picture of the complete railway engineering, not just simple project management skills in order to successfully implement multidisciplinary approach.
That's invaluable advice, Ivan. Your emphasis on a well-rounded skill set is a great advice for engineers. Now, looking to the future of interlocking systems, what advances in electronic interlocking and modular signaling, how do you see interlocking systems evolving over the next decade?
Well, now what we actually have is this first evolution step, going from, let's say, usually or ordinary electronic interlocking to the digital interlocking, or as it's called the DSTW, German term, but relate to digital interlocking device. So basically, some of the hardware elements and functions are actually located in some kind of cloud environment, so they're not physically present on the site, which reduce the quantity of the physical equipment, so you can have smaller buildings, smaller signaling rooms, and so on. Of course, this now brings the other topic, and that is the protection of such kind of infrastructure, especially from cybersecurity attacks. So on the other hand, you have a very good evolution of the hardware, reducing the level of equipment, but on the other hand, you need to have raised software protection, including cybersecurity. For example, now it's, I think, already looking for the development of the quantum computing. Now it's not far away that the first quantum computers will be commercially available, and that means a vulnerability of many systems, including railway systems, to this kind of equipment, because they can process much more information, easily break the passwords and levels of protection. So in this sense, with the digital signaling, you need to have additional cybersecurity protection, and we also have here some contacts on Serbian Railways with several companies who are providing these services. For example, Silos, probably the most known in the railway world. We had some initial discussions with them. They offer some portfolio for protection, and this is more or less something that all infrastructure managers who are switching to digital signaling will need to consider also as additional protection of the signaling infrastructure.
Wow, Ivan. Digital and cloud signaling paired with advanced cybersecurity. Wow, this sounds like a game changer. Now, shifting to lessons learned, reflecting on your experience, what would you say are the top 3 lessons for the engineers and managers embarking on large-scale signaling projects?
Depends what is actually, except some general, let's say, requirements which you need, which you want to achieve with your project. You have better technology efficiency and so on. So basically, I would say that first, very important to when you do something, that you achieve some kind of wider interoperability. For example, if you are building the TCS line, you need also to pay attention, especially in cross-border implementations between states, what is done on the other side of the border, how you will create this transition from one country to another. So this general interoperability is very important. So it's not just that you have high-tech, but this high-tech is interoperable with something which is near it. Then, of course, the second, from my opinion, you need to have some operational benefits with this technology. This is I would say that the most important and most visible gain of this project. So for example, if you need shorter headway trains, then you need to have also the higher speeds, and then forces you to bring new technologies like ETCS or CBTC. So the operational benefit is important, and because this can be measured in number of trains and consequently in number of passengers or goods which you can put through your network. And also finally, but not least important, at least this is my impression, that you need to be ready to permanently learn and adapt new technologies. Unlike 1990s and 2000s, where there are technological gaps, but they maybe happen 1 in 10 years, like with the electronic interlockings and ETCS. Now the technology evolves faster. There are many new things, so you need to follow this to permanently learn. I personally take just this year 3 or 4 courses from some interesting trainings from ETCS level, from IRSE. So basically you need also to work permanently of your knowledge, because now technology really changes faster than before.
Agreed. Really great points, Ivan. Finally, what excites you most about the future of railway signaling and telecommunications, of course, and where do you think the biggest opportunities lie in the future?
Yes, from my point of view, and I think that most of colleagues would agree, this definitely will be the application of AI technology generally in railway engineering, and also specifically in signaling and telecommunication. For example, I personally in the last few years use several tools to try to improve some of my work in design phases. Let's say, for example, when you work with some really large railway station with big number of tracks, switches, signals, and you prepare the control tables, it's still done manually, but the possibility of error exists, especially it raises exponentially with the complexity of the station. So I personally use some small tools, preparing some applications at least to help me generate properly all the possible paths between big stations. So this is nothing too complicated. It's used in MATLAB or Mathematica, but it helps me very much in shortening the time for preparation of control tables, and also for eliminating the errors in the beginning. But of course, there are much more advanced examples of AI technology. For example, for now, it's all mostly in the predictive maintenance. We also helped our infrastructure manager to buy another tool for predictive maintenance of Euroballises, and which showed already good results. So basically, you go put this mount this on the train, go over the line, and it measures physical parameters of the Euroballises, so current, voltage, frequency, and it gives very good prediction about the lifetime of Euroballises. So if you have a problem of someone, it indicates that there is a problem, then you can contact the supplier in advance. He can check this is really something. And we had the cases that 3 or 4 Euroballises are already replaced after 3 years of operation. It's not too big compared to the thousands of total quantity, but it detected on the time that they will have, although the trains were going regularly and receiving telegrams properly, the physical characteristics of Euroballises degraded, so tool indicated that they need to be replaced. So for now, the predictive maintenance is, I think, something which is already reality, and in the future, I think also the safety critical operations, for example, like route control in interlockings, and especially traffic optimization in CTC and TCMS systems. I think this will be next field for application of AI. Of course, still needs some kind of evolution to reach these levels for safety critical operation like railway signaling, but definitely this will be the future. So I think that the AI in signaling telecom will be very important in the following years, and it will help both engineers and operation people, maintenance people to shorten some usual operations which are now mostly done manually.
Great insights, Ivan. It was amazing talking to you, and thank you so much for sharing your thoughts on this podcast and sparing your time with us. Thank you so much.
Thank you so much, Akiman, for invitation. It was my pleasure to be in this podcast, and of course, I'm looking forward to some further participation. It is always a pleasure to be your guest. I believe everyone listening to this podcast has got something to take away from today's discussion. If you like this podcast, please listen, follow, and share this podcast within your network. If you believe we should be sharing your story or someone within your network, there is a railway leader who should be here sharing his or her contribution to this industry. Contact me on railway transportation systems at gmail.com. Thank you for your time today. Stay safe and take care of yourself.